Welcome to All This Math. This is Professor Parker, and today we're going to be solving some equations. All right, now, what I want you to do first is just take a look at this equation right here. Just look at the equation, look at how many terms it has, look at check for where your variables are, look at your coefficients. In this case, we have fractional constants and fractional coefficients. Constant, coefficient, constant. Now, to a lot of people, a lot of students, they see a question like this, they see a problem like this, and they just start folding. They don't even want to try it. And that's understandable. I'm going to just keep it real. That's understandable. It's understandable because they probably have never really encountered questions like this. And also, it's the fraction part. There are a lot of fractions up here. A lot of students have not been well versed in how to navigate fractions, how to do arithmetic with fractions, how to do anything with fractions, for real, for real. So when they see an equation like this, they look at it and they're like, nah, I can't mess with that. I don't even know where to begin. It just looks too complicated. But here's the thing. Even if you don't understand fractions really well, there's a way to solve an equation like this that enables you to, as a first step, eliminate all the fractions. So it's cool. If you don't like fractions, cool. I'm going to show you how to get rid of them, right? A lot of textbooks call this clearing out fractions, right? Solving equations by clearing out fractions. All right. Now, you will have to know a little bit of background knowledge or have a little background knowledge on fractions in order to do this, because you'll have to figure out something called the least common denominator, more commonly known as the LCD. All right. So I look at this problem, and first I take an account of all of the fractions, well, all of the terms really, and I look at all my fractions. I got 5/3, I got 2/3, right? Next to the x, I got 25/12, I got 5/4, and I got 3/4 right here. Now, what we got to ask ourselves is, what is the LCD of all those fractions, right? Meaning, what is the L in the LCD stands for least, the C is for common, the D is for denominator, so LCD. What is the smallest number that all of these denominators can divide into evenly? That's what we got to ask ourselves. And we end up figuring out that it's 12. Because 3 times 4 gives me 12. 3 times 4 again gives me 12. 12 times 1 gives me 12. 4 times 3 gives me 12. And 4 times 3 gives me 12. So 12 is the smallest number that all those denominators can divide into. So once I know that, I'm going to just write that on my paper somewhere. I'm going to write LCD is 12. All right? And then what I do is I'm going to draw brackets around the entire equation. Right? So our first step is to figure out what the LCD is. We did that. Second step, we're going to draw brackets around the entire equation. So the brackets look like this. All right, so we got our equation inside brackets. Now, the purpose of putting it in brackets is because what we're going to do is we're going to multiply every term inside the equation by that LCD. That was the purpose of us figuring out the LCD. Now, what is that going to do for us? That's going to enable us to get rid of all the fractions. Watch. Magically, all the fractions are going to disappear once we multiply each term by 12. So I'm going to write my 12 out here. I write my 12 out here so it'll kind of look like we're using the distributive property with parentheses. All right? So first thing, I do 12 times 5/3. Now, what does that look like? What I'm actually doing is I'm doing 12 times 5, which is 60, and then I'm taking that product of 60, I'm dividing by 3. 60 divided by 3 is 20. So this 5/3 turns into a 20. All right, and again, I did 12 times 5, which gave me 60. 60 divided by 3 gives me 20. An alternate approach could have been this. I could have did 12 divided by 3, which gives me 4, and then 4 times 5, which also gives me 20. Either way, I get 20. Either way, 5/3 times 12 equals 20. Either way. I do the same thing with 2/3 x. So now I do 12 times 2, which is 24. Divide that by 3, that gives me 8. So now I got 8x. And just like that, these two fractions are gone. I created terms that have an equivalent value based on multiplying the entire equation by 12. All right? But the important thing is that the fractions are gone. We're getting rid of fractions. Now, 12 times 25, I'm not going to do 12 times 25. I'm going to do it the other way that I showed you, where you can also divide 12 by the denominator So 12 divided by 12 gives me 1, and then I take that 1 and I multiply by 25. So it's two different ways I can actually do the multiplication. You can either divide first and then multiply, or multiply first and then divide. Either way. Then this one, 12 times 5 gives me 60. 60 divided by 4 gives me 15. So now I got 15x. And then I got 12 times 3, which is 36. And then I'm going to do 36 divided by 4, which is going to be 9. So I got plus 9. So this is my new and improved equation. And just like that, all my fractions are gone. Just like that. That's how you get rid of fractions. So if you ever see an equation with fractional coefficients, fractional terms, and you don't like fractions, you can get rid of them, right? You can just get rid of them. Figure out what the LCD is, and then multiply the entire equation by the LCD, every individual term by the LCD, and somehow magically, right, the fractions will be gone. Now we got an equation with x's on both sides of the equal sign. So what I suggest in this situation is we kind of organize this equation. We kind of clean it up a little bit, right? I use a method called transposing. I'm a heavy advocate of transposing. I don't know. Some people might not like this method, but I like this method a lot because it's efficient, it's effective, it's straightforward and to the point. All right. Now, what transposing means is you take certain terms and move them to the other side of the equation, right? Like I can move this 15x to the left side of the equation. I can move this 20 to the right side of the equation. Now, why do I want to do that? I want to do that because what's going to happen is I want all my x terms on one side of the equal sign. And I want all my constants or my regular numbers on the other side of the equal sign. So I want 8x with the 15x. Because when I do that, then I can combine like terms. Because I can't combine like terms when the terms are on opposite sides of the equal sign. So this 8x, I can't combine it with the 15x. Because remember, we're trying to solve, and in this case, we're solving for x. But we can't solve for x unless x is in one place. Right now, x is in two different places. So we got to combine these x's. But we can't combine the x's until we put them together on one side of the equation. So watch this. I'm going to slide this 15x over to the left side. And I'm going to slide this 20 over to the right side. All right. So now, once I do that, I'm going to have all my terms like organized and like together on their respective sides of the equation. But it's one thing you got to remember. Whenever you do this, whenever you transpose, you have to change the sign of the term that you're transposing. So when I move this 15x over, it's going to become negative 15x. It was positive, but now it crosses the equal sign. Once it crosses the equal sign, now it's negative. And the 8x was already over there, so that's still positive. And now the 25 was already on the right side, so that stays positive. The 9 was already on the right side, that stays positive. The 20 was positive on the left, but it crosses the equal sign, and now it's going to be minus 20, right? So now we got our problem more organized. We got our x terms on the left-hand side. We got our constants, or our what we call regular numbers, on the right-hand side. And now what we're doing is we're going to actually combine like terms. Combine like terms. All right. So once we combine like terms, now we say, okay, what is negative 15 plus 8? Negative 15 plus 8 is negative 7. So now we have negative 7x. Then on the right-hand side, we combine like terms again. 25 plus 9 is going to be 34. 34 minus 20 is going to be positive 14. All right. So now take a moment, right? And just look back at the original equation. All of this equation had going on. And through our work, through our clearing out the fractions, our transposing, and our combining like terms, look at how simple it is right now. Now it's just negative 7x equals 14. All of this was condensed and simplified into just negative 7x equals 14. So now we just got one step left. We want to isolate the x, so we want to get rid of the negative 7. Now, how do you get rid of the negative 7? You do the opposite operation from what the negative 7 is involved in right now. Negative 7x really means negative 7 times x. So that's a multiplication statement. The opposite of multiplying is dividing. So we're going to do that in order to get rid of the negative 7. And really, we want to turn the negative 7. We don't want to just get rid of the negative 7. we want to turn it into a positive 1, because then you'll have a 1x. And we know that 1x is the same thing as just plain x. So I divide by -7 on the left side. But in an equation, if I do an operation on one side, I have to do the same operation on the other side. So I need to also divide 14 by -7. So now I cross these out because they become 1s. 1x divided by 1, as I said, is just plain x. And now I have 14 divided by -7. So 14 divided by -7 is just -2. Now remember, a positive divided by a negative is always equal to a negative. This should not be positive 2. Don't make that mistake. 14 divided by -7 is -2. So this is our answer. X equals -2. All right. Now, remember what we did. We saw an equation with fractions in it. We cleared out the fractions. That's what we did at first. We cleared the fractions out, got rid of them, right? Then we transposed to kind of organize or clean the problem up. I wanted all my x terms on the left-hand side. I wanted all my constants on the right-hand side. We did that. Then we actually combined the like terms, put all the like terms together, so we have x in just one place, and then all our constants were combined into one term as well. And then we ended up with -7x equals 14. And then we would just divide by -7 and divide by -7 to get our answer. Now, normally, what I would do is you would check to make sure that this is correct. You will plug in -2 here for x, and you plug in -2 here for x, and you make sure that the left side is equal to the right side. Now, I'm not going to do that right now in this particular problem in this video. I'm going to allow you to do that to make sure that the answer is correct. But I'm sure that this answer is correct already. But I want you to make sure that you know that this answer is correct. All right? So now, thank you for tuning in. Please like the video. Please subscribe to the page if you haven't already. Tell some people about it. You know, copy the link, send it to some people, send it to your classmates, send it to your friends and family, whoever, anybody that's taking an algebra class, algebra 1, algebra 2, whatever. I just want people to understand how to do this. All right? So, thanks for tuning in, and please remember that there's all this math all around you.